Good afternoon, everyone. Am I audible? Okay, fine. Let's continue our discussion is communication. So, to start with interprocess communication, there are many. So, let me share whiteboard. So, interprocess communication. As I mentioned, there are many ways of doing so. So, very first and the simplest way is making use of pipe. So, pipe is kind of a FIFO mechanism, and as you know, FIFO is like first in, first out. Pipe can be utilized to send between two processes right into the pipe, and from other end, other process will read it. This is mostly used in operating, even whenever you are making use of some sort of shell. So for example, if I do something like cat abc.txt, now this command is used to see the contents of file abc.txt, and now here we can make use of pipe symbol, something like this. This is a bar, and here we can execute another command, something like grep, or maybe something like this, wc minus l. Now what is meaning of this is simple. Say for example, let me draw it. So for example, pipe is something like this, wherein we are aware of the pipe used. Is it visible? Because somebody's whiteboard is not visible. Can you see the whiteboard? Okay, it is visible. Fine. Maybe a small delay is there. Fine. So let me repeat it. We are talking about interprocess communication mechanism, and very first thing is the pipe. Okay. And now I selected one shell command there, where I'm in cat abc.txt. Now this hub command, I'm saying cat abc.txt, is used to see the contents of abc.txt. Okay, so that means whatever ASCII text of this symbol there, vertical bar available on keyboard above T, or I can say below backspace. Okay, now that is a pipe, and like we make use of pipe for transmission water supply, right? So it is that kind of a pipe, where now one command will be executed here on this side of the pipe. So something like cat ac.txt, and whatever the output of this command is there, okay, whatever output of this command is there, it will go inside. Fine. it is something like abc.txt. Out of this will go through this pipe, something like this. It will travel through that. And let me tell you, that can be utilized as an input for the next command, for example, called as wc-l, where wc is the command called as word count. By default, it counts character, word, and number of lines in your document. And if file is not mentioned, it will try to take the input from standard input device. Rohit, mute yourself. WC is like word count, and I just use -l or -l there. Meaning of that is just because by default this command counts number of characters, number of words, number of lines. Now I just want to get like how many lines are there, so I use WC-l. Okay. Now the pipe can be of two types. This pipe PIPE, one is called as unnamed pipe and one is called as named pipe. Unnamed pipe and named pipe. Now unnamed pipes, it has got some sort of restriction. Now they can communicate between related processes only. I repeat, unnamed pipe can be used for communication between the related processes. Now, whenever I say related processes, what is the relationship? We know that it is the parent and child relationship. Okay, so parent child relationship is okay. Here only you can make use of this pipe. Whereas named pipe can be used between even unrelated. So any processes, they can be used between any processes, can communicate making use of named pipe. Okay. Now, because unnamed pipe is utilized for communication between parent and child, definitely we need to go through fork system call. Now let me share the terminal. Can you see this terminal? Is anybody please respond? Can you see the terminal? Okay, no problem. Fine. Open manual page for the pipe. So man pipe, but now it is coming from section 8. No, that is not required. We need to either from section or from section 3. Now it is from system call. So there is a header file called as unistd.h and it supports this pipe function or system call whose return type is integer, and we need to pass two integers. We need to pass the array of two integers. Okay. Now why two? Why two are required? And that is where again when you create a that is used for unidirectional data flow. Actually, it supports two descriptors or file handles, or rather in simple terms you say file po. Know that what is file descriptor or file po. Whenever we open any file, say for example fp is equal to f open, something like that, kind of a file pointer, and depending upon the mode open the file, either you can read file is opened in read only mode, or you can write to the in write mode. Pipe needs two file descriptors. One file, for example, if you see it here, file descriptors. So reading purpose for writing purpose. Which is for reading and which is, remember, you can write to descriptor of one and you can read through file descriptor here. That means descriptor of 0 is used for reading purpose, file descriptor of 1 for writing purpose. Type system call two for reading purpose and for writing purpose. So very first step is you need to declare an array of integer. So something like int fp of 2 and pass this to the pipe system call. So on success it returns two descriptors, fp of 0 for reading purpose, fp of 1 for purpose. After that you need to make use of fork. I repeat, after that you need to make use of fork. So if again I go back to let me stop sharing this and go to the whiteboard. Here for example, what happens is something like this. Very first step is declare a file descriptor array of 2 and pass this to the, okay. So here what happens is this f of 0 is used for reading purpose and fd of 1 is used for writing purpose. After this you need to make use of fork system call. Now what will happen with this fork, the fd, two fds will be automatically replicated again. Okay, that means whatever the parent process is there, suppose this is the parent process and this is the child process, and in between somewhere we have this kind of a pipe, and let us assume that this pipe is something like fd of 1 here and fd of 0 is here, somewhere here, fd of 0. So there are two ends, right? So fd of 0 is here. Now these, because we use pipe before fork, fork duplicates everything. So this pipe is also like shared between, now if I call this as process, let me call it as a parent process, and let me call this as a child process. So fd of 0 is available in also in child, fd of 1 is available in parent, also in child. So it is available there. But in order to have a proper communication between parent and child, so this pipe For example, talking in terms of logically, something like this. If I say this is FD of 1 and then say this is FD of 0, something like this, the same pipe is replicated in parent and child to have a proper communication, some write data. Now, even though you can see here two different pipes, one's for parent and one's for child, pipe is kernel data structure, so only one will be there, that is shared between parent process and child process. So one has to be stopped. Like for example, suppose parent want to write something, parent will close something like FD of 0, something like this. So this will not be available for parent, and child will close something like FD of 1, and whenever parent will write something, it will go to the pipe through FD of 1, and the same thing will be read by the child through FD of 0, something like so. This is the path. Okay, so this is how two related processes can communicate with each other. Please make a note of this. Pipe be used for bidirectional data transfer. It is unidirectional data transfer. It is unidirectional data transfer. Whenever you want to have bidirectional communication, you need to create pair of pipe that must be created. Okay. There is one question on chat, sir. Please, can you explain pipe command on terminal again? Okay, fine. The terminal, share the terminal, and this. Let me check if any text file is there. What I'll do is I'll execute calendar command, and output of this calendar command will be stored in cal.txt, for example. And now I want to see what is the uh, whenever you want to use cat command. So cat is used to cal.txt to see the contents of file. So cat cal.txt is like it shows the content. Now, how many lines are there? For that, what we do is wc command is used. So if I say wc cal.txt, it says now how to read this. Initially, it gives 8, that is number of, then 39, that is number of words, and 188, that is number of characters, and name of the file is cal.txt. Okay. Now, see, actually WC works with standard input. So without any file name, if I execute WC, it is waiting for input. So the sample input on second line. Now I want to stop something. I'm some randomly typing something and say bye. Okay, and end of input that should be given with mistake here. Sorry. Out of this. Let me stop sharing this and I'll open it again. Because by mistake I pressed combination of Command D on my MacBook. That is wrong. So say WC, I just press enter. This is sample input. I am continuing on many lines by something like this. And if I press D, the combination is Control and D. So I press Control D. So that is end of file rather. Now here if you see WC standard input lines 5 because one blank line is also there between many lines and by. Number of words are 11 if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So on first line 3 words, on 1, 2, 3, 4, 5 words, then 2 and then 1. So 11 words and number of characters are 57. Okay. Now that is typically used. For example, if you want to use pipe there, cal. Now what I do is wc cal.txt. I use. I think I deleted that. So output of cal and wc cal.txt. It is something like this 839 and 188. Now no need to save output of cal into the file say cal.txt and then use wc. We can combine these two commands into a single. How? It is something like this cal, then make use of pipe command and then use wc, something like this. You'll get the similar kind of output. So cal pipe. So here let me tell you, I guess you already implemented one of the assignment of implementing shell where each and every command is executed in another process, right? So here cal is one process, wc is another process, and I'm using some sort of pipe. Now you may wonder, is it unnamed pipe? And if it is unnamed pipe, cal and wc, are they related, parent child? No, definitely not. I am talking about pipe system, pipe. Okay, that creates a unidirectional channel of communication between related processes. Got it? Again, if I see the manual page of pipe, so many options are available there. Okay, it should be to pipe, something like this. Okay, and now how to read and write is very simple thing. You simply go with read and write, like you are reading and writing from the files. Okay, exactly same way. You just make use of fd0 for reading purpose and fd1 for writing purpose. Automatically communication will happen. There is one more question. Repeat the read write for child and parent. Okay. So for example, whenever you do some sort of a fork, here for example, whenever you do fork, now what we do, let me use utilize here somewhere. Something like this, or let me try it here. When you do fork, right, with some sort of PID equal to 4, it is not scrolling down actually. So I'll simply again I'll share the whiteboard. Okay, fine. So it is something like PID is equal to fork, and then what we do is if PID equals 0, that means it is the child process, right? It is child process, and in child process what we do is FD of, or rather I can say close FD of 1, because child don't want to write anything, and you can read that data from FD of 0 and whatever other from something is required. And in else part, that means it is the parent process. What we do is we'll close. Remember, I'm not using F close because these are system calls. Okay, so I'll close parent process FD of 0. That means parent don't want to read it, and parent will send data using write FD of 1 and whatever other parameters are required for write, that buffer and length and everything. So whatever the thing written here by the parent from write for the child process to read it. Getting it, no? Any doubt in this? Any doubt in this? Okay. So that is, but again remember here fork is must because they are related processes. Just a minute. Fine. Can have a named pipe. Now working of that is exactly same like this. Only thing is I'll show you. Again, I see here from sys MK node, and if you give the type of device as a pipe, that will create the name. Okay, so named pipes, as I mentioned, can be created making use of even MK node can be used as uh, just a minute. MK node is actually command. MK info is the system call for that. Yes, that is used for make a FIFO file where like use as the same like pipe. Only thing is it has some sort of a name. Let me annotate that part. It is name. So some sort of path is given there, and because path is given there, what happens is it is file is created. Okay, and this mode is like the permissions you can specify, and the same file can be opened by multiple processes, maybe for reading purpose and maybe for writing purpose. Okay, so that is what the uh, communication part is through read write close. It is very simple thing, like you create a file, you write into that, you read from that file, you close the file. Similarly, MKPIPO creates the name type, read and write calls can be utilized for reading and writing purpose. That closes the. Okay, let me show you. I don't know if it works here or not, but let me check that. If I say mk node my pipe p, I think first of all I need to give type. Node type must be B or C or no created here. But on Linux you can try this, where you can create a pipe there. Let me check if something else is there. MK is there. Yes, MK my pipe plus hyphen L pipe. Here you will see that the most important thing. I purposefully done the long listing with hyphen L. The reason behind that is now you can check the very first character there. Very first character listed there is P, and that means the type is pipe. Now, whenever anybody want to, it is something like what I'll echo hello from my pipe. See, it is just displayed there, and the same I want to put into the my pipe. Try to understand, because I did the same thing. Cal and output of cal directed it to cal.txt. Exactly same thing I'm doing here. I use echo, or now let me open one more tab. New tab. So this is one tab where I put hello pipe, and now remember it is blocked. So this is a blocking call. Not available for me. Okay. So what I'll do is now ls hyphen l my pipe. Yes, it is available there. Okay. Now this shell where I write something into the pipe is separate process. This shell is separate process. Now what I'll do is I'll try to read the contents of my pipe, and you will come to know that my pipe, when I did from some another terminal, I got the message hello from my pipe, and whatever the previous process which was waiting there, right, that is exited. So unblocked rather. Similarly, say output of calendar, or now if I do exactly same thing, if I try to cat my pipe first, try to read from the pipe, but there is no data in the pipe. Okay, so what I'll do, put of calendar, I'll forward redirect it to my pipe. See, immediately it is coming out of this. Why? Because somebody is trying to read the data from pipe, and that is the another process. See, here we are getting. So I executed command there, and I'm getting output here, something like this. So for inter-process communication, now this is an example of named unnamed pipe can be also utilized. Any do you have anything regarding this? Otherwise, now I'll move to IPC, because that is again important part, and we'll see shared memory part. So next is the shared memory. Fine. So let us start shared memory. Now POSIX shared memory is also available, and system V is also there. Now we have already saw some examples on system V. Sorry, POSIX like semaphores. Now let us see system V or system 5 IPC mechanism, interprocess communication. For that, let me share a small program for that. So I'll share that. So let me this. Yes. There are two programs, SHM Writer and SHM Reader. Shared memory writer. So two processes will be actually there. One process will write at the location shared memory and another process will try to read it from. Okay. Now let us start with the small program. Four statements are there, not more than that. But now we need to understand first upon ipc.h, this required sys/ipc.h. Remember, this is required for system V interprocess communication. sys/ssm.h is also required. This is for, okay, same.h is also semaphores. But now we have seen the example of POSIX semaphore. So H. Now, in order to look for system V IPC mechanism, the most important concept is key underscore T key, and this data type is coming from ipc.h header file. What is this key? Remember, all these IPC mechanisms will the kernel's data structure. It is kernel's space. And in order to identify each and every data structure you created, you need to provide some sort of, for example, it could be any random integer also. For example, if I say 1, 2, 3, 4 is my key, yes, you can directly use that also. So key underscore T, key is equal to 1, 2, 3, 4. No problem. But then the problem is if another programmer use the same key, problem. And in order to generate this key randomly, there is one function called as f2k. There is one function called as f2k. Okay, and this f2k, let me open terminal here. Man f2k, meaning of this is key. This creates the IPC identifier name. So what we need to pass is path. Okay, that is more than sufficient, and some sort of ID, anything, you know, anything, any random number, no problem. Now both the things will be combined together in some sort of a key, and that is used to uniquely identify the IPC mechanism. So for example, I just use something like SHM file. This file must present. Okay. So for safety, what I can do is, time is SHM writer. So I'll use this SHM writer.c because I know that this file will be definitely available there. Right. So this creates a key. Now the next get meaning is get the shared memory. Okay. Shared memory segment, again if I go to the terminal, map get, this will get. So what the things you need to pass is this memory identifier created with key. So that means the important part is if it is already created, you will get. Not created, you need to pass the flag called as IPC create. So for example, in this program, I use that IPC create. So try to get the shared memory segment key. If it is not available, create it while creating, make use of these permissions. 6 and 6 is like read, write, execute permission is not available here. Remember, this is octal number because it starts with 0. I already mentioned this part where meaning of read is 4, meaning of write is equal to 2, and meaning of execute permission is equal to 1. So it is combination of 4 plus 2 plus 1. All permissions are given, the value is 7. I use 6, that means it is 4 plus 2. That means read and write permissions are, and size is 1024, that is around 1 KB. Okay. Access, meaning of this is in the kernel's space 1 KB of space, that is shared memory, will be allocated, and it will return, it will be uniquely identified by its we have passed, and what it returns is identifier for this shared memory segment, and that I assigned it to SHM ID, shared memory segment identifier. Okay, once we get types of, right, what are those? One is called text region, and then we have stack and heap. There is no boundary for stack and heap, something like this. Now, whatever this shared memory segment that is created in kernel space, that is created in kernel space. So, your process cannot access it. You need to attach this current process. And for that, the call is SHM80. Attach the shared memory to your process. Now, where to, for example, now I want to store string. So I character star. If you want for integers, maybe you will go with int star, no problem. Because whatever the shared memory segment is there, you trust it because the starting address will be given by SHM80. So what happens here is attach this shared memory. I am passing null here because 0 is converted to void star. So that is null. And whenever you pass null to it, meaning of that is find the appropriate location in current process where to attach it. And wherever is it is attached, that address will be assigned here. So character star str is equal to getting some sort of address. Now because I converted it to character star, I can now make use of fgetS. So making use of standard input device, I want to read something, and whatever I read will be stored in the shared memory segment here, somewhere here, not to my current process. And then I'm simply saying data written in memory at the location str. I just want to display that. Once you done using shared memory segment, you can detach it. So call is SHM. So the steps are very, very simple. 3 steps I can say: SHM get, SHM AT, and SHM DT. All 3 calls will be SHM.h header file. So this is how one process can. Now how to write, that is again important. Oh, we have written it in the shared memory. Now how to read it from another process? Same kind of thing is there. Now you must pass the same F2K, shm underscore writer dot c, something like shm underscore c. That is the path I have given. the same ID I have given 65. So definitely it will return the same thing. Okay. SHM get, even though I use create here, no problem. If it is already created, then that will be written back here. Now thing to character star, and this time I just want to display it. That means I want to read the shared memory segment. So reading and shared memory segment, there are no specific functions because it is memory. Memory can be accessed through names of variables only. So whenever I declare say variable int I, what do you mean by writing to it is something like I is equal to assigning some value. Say I is equal to 30. That 30 will be written at that location. And whenever you want to read it, you can simply maybe for example printf %d I. That means I want to read it and display it. That's it. So that is what read and writing is there. So no separate system calls or function for reading and writing to and from shared memory. Once you get the pointer, now you can make use of that pointer. The same thing I am doing here. I am trying there. Okay. Detach the shared memory segment, and at last SHMCTL. This is used to destroy the shared memory segment, because with detach you are just it will be still there in the kernel space, and if you really want to remove it from kernel space, make use of SHMCTL with IPC RMID. IPC RMID, constant use to remove the IPC mechanism by its ID, and that ID is given as the very first HM ID. Okay, compile this and we'll execute it. So what I'll do is, let me first of all save both. Open the terminal. What I'll do is, I'll move to let us see shm star.c, shm reader and shm writer.c. So two files are available there. I'll compile both. I either use clang or gcc, no problem. Shm writer.c out want is as a writer, something like this. Similarly, I'll compile shm reader.c because both are in the same folder, overwrite a.out, and that is the reason I'm just giving name writer and reader. Okay, now definitely I need to first upon execute writer. Reason behind that is reader will try to destroy the shared memory segment. Okay, so let me execute writer first upon. So writer, it create a the shared memory segment, and it says write data and whatever I type. So hello from SHM or hello from shared memory. Let me enter. Now what it says, data written in memory. Remember that the writer process is terminated. Okay, but still the shared memory segment is available the kernel's space. So whenever I execute reader, say when I just executed reader, whatever data the writer process is available here. Hello from shared memory. If I again try, definitely I don't get anything. Reason behind this is when I executed reader, it has destroyed the shared memory segment. Okay. Any doubt in this? Any? Is it clear? How to of shared memory for inter-process communication. So today we have covered pipe, named and the memory from system VIPC. Okay. See here one of the problem is we have not synchronized the reader. So if you combine it semaphores, that is actually good thing. Reader has to wait for the data. So some sort of semaphores can be utilized for that purpose, where whenever writer writes, it will be, and reader has to wait on something. Okay, so that is end of today's lecture. What is meaning of hyphen o writer? Aditya Kabale. Uh, I think this question you should have asked in the first semester of second year when you use GCC first time. Okay, but still, let me tell you what happens is whenever you compile a set, let's see, I compile this, what happens is it creates executable file called as a.out, right? And if I again compile shm reader.c, this also creates. So whatever the a.out for writer program will get overwritten, right? And that is the reason what I did is I make use of hyphen o, something like this, writer, shm writer, something like, where this is this file, and whatever the output file is created, create a.out, name it as a writer. That means name of executable file will be. So same thing I did it for reader. So while executing, I executed from writer and reader. So dot slash writer and dot slash reader. So two separate executable files will be there. If you don't give it, out will be created. And if you execute two separate programs, previous a.out will be overwritten. Okay. So that is the idea behind it. Okay. So we'll stop here today.